Thank you very much, Dion and Datamine, for inviting Glass Expansion to come along today. So today I'm going to talk about maximising performance and minimising downtime of your ICP. So first, a little bit about Glass Expansion. We were formed in 1983 and we manufacture sample introduction components for your ICP OES and ICP MS. Over that time, we've proven a track record for innovative products. One of the things we're renowned for is working with high precision machining of plastics, glass, metals and ceramics during that time. So we can supply everything from your auto sampler probe all the way back to your RF coil and everything in between. We're actually OEM to every ICP and ICP-MS manufacturer. We have over 100 staff and we have an extensively equipped ICP. So we have 5 ICPs there. We have 3 ICP OES and 2 ICP MS. So we use that for R&D testing. So when you get your product, we know it's going to work. So we invest about 10% of our revenue back into research of these products. We have 3 locations. So in Australia, we are based in Melbourne, Port Melbourne. The other 2 locations are in USA and in Germany. The manufacturing is in Port Melbourne. So many of our products have actually become industry standard today. Some of the products you may be familiar with is a cyclonic spray chamber, a U-series nebulizer, such as a sea spray, micromist, conical or slurry. In fact, the micromist today is the biggest selling nebulizer worldwide. Helix CT interface, so that's that piece here. Guardian inline particle filter, a D-torch, we have a patent on it with a ceramic outer tube, a chilled ice mist spray chamber, and our Elegra Argon humidifier. So today I'm actually going to talk about some of those products and how they can help you minimize downtime and also improve your performance. Concentric nebulizers. So the way we manufacture our nebulizers, we take thick wall bore tubing and we actually machine from the tip, the unifit, all the way to the tip of the nebulizer. That way we can control the concentricity all the way through. It's the same precision all the way through, as opposed to grabbing a piece of glass, hitting it and drawing it out to catch that, create that capillary. By doing it that way, we have 0 dead volume and we use that unifit that slides over the end for your sample inlet. You'll also notice now that our Argon connector is made of PEEK. So no longer do we have that, if you like, that garden hose clip-in, clip-out mechanism, which has a metal spring in it. One of the things we're looking for, metals. So we removed that now. The advantage of having that PEEK connector allows us now to actually have specific gas connections directly to your instrument. One of the advantages of having those U-series nebulizers, the reason it was first we designed that, was so that we could actually take a HPLC connection and hook it directly to your U-series nebulizer by using these high-pressure interface kits. Since then, many of our customers have actually been taking these high-pressure fittings kits, putting them onto the nebulizer, and actually using them to connect to those high-throughput valves that you might perhaps be using. There's a lot of back pressure from times with them. That gives you a nice, neat, snug fit. And then you don't have your fitting blowing off, creating a pool of water, and hopefully it doesn't damage your ICP. So the current nebulizers that are out there at the moment, we call them DC nebulizers. DC stands for direct connection. So what we do is have that PEEK ratchet connector that comes factory fitted on your nebulizer gas arm. And then we're allowed to, that allows us to provide a ratchet connector. Now the ratchet connector is a little bit like the petrol cap on your combustion car if you still have one. As you tighten it, you cannot over tighten it. There's a ratchet mechanism. So what's finger tight? Now we know what finger tight is. You can't over tighten it. So if you've got different operators moving through the lab, especially if you're running 24-hour lab, then it's much easier to control different people using that instrument. It's finger tight each and every time because it has a ratchet mechanism. We now supply soft gas tubing between that ratchet mechanism and the instrument. Now each DC gas connection, direct connection, we supply specific gas lines. So the end of the DC gas fitting pushes straight into your instrument. There are no metal components at all. So if we know what ICP manufacturer the instrument is, if we know what model you have, then simply all we do is add a prefix in front of the part number and you finish up with the direct DC gas line. So here's a range of different gas lines for all the different ICPs, the more common ones. No metal components. All have ratchet connections and all have soft tubing. So what are the benefits of the DC nebulizer? So what we have is inert metal-free argon connector now. The ratchet fitting ensures leak-free gas connection. And each gas line is specifically matches your instrument. So in spray chamber designs, not all spray chambers are equal. So the first one is the drain fitting. It's a unifit connection. So if you've ever used PVC tubing on the end of the drain, you'll know that the chemicals that you use finish up bonding that PVC to the bottom of your spray chamber drain. When you go to take it off, you either have to scrape it away or you finish up cutting yourself. Hopefully you don't do that. What we have is these unifit drains that slide on. They're made of Teflon. Teflon will not fuse to glass. This is a twister spray chamber. The baffle in the middle there is actually fused to the bottom there, so you don't get build-up of droplets hanging on the end, affecting your RSDs. We know that by having vertical walls on your spray chamber, maximize the efficiency of the spray pattern. On one side of the spray chamber, we actually put a groove up the top. That's so that when the sample comes in and goes around the spray chamber, that excess sample hits that groove and flushes out the spray chamber much faster. And then we have what's referred to as our Helix CT connection. There are two components there. One is our Helix CT locking nut, and the other one is the Helix CT seal. The purpose of that is so that sample, which is here, it can't sit in that, it's actually forced into the vortex. There's no dead volume there anymore. That Helix seal sucks up that dead volume and sample is forced into the vortex, giving you faster washout. The other purpose of the Helix CT is so that you have to slide the nebulizer all the way in. And when you lock the Helix spray chamber in place, the Helix locking nut, the tip of the nebulizer is in the exactly same position each and every time. So you don't get variability from one user to the next user. If you were to try and insert the nebulizer halfway, the Helix locking nut will not work. It's designed to lock on the 6mm part of the nebulizer. So we're engineering that from one user out to the next. You have to, we're forcing you to slide the nebulizer all the way in. Same position each and every time, reproducibility. So the Helix CT interface, I said it consists of two components. The CT stands for constant torque. Okay, it's a little bit like the ratchet again. We know that if you tighten it and there's no ratchet mechanism, you can over-tighten that nebulizer. You're actually putting pressure on that capillary. And in doing so, you're actually restricting the flow. If you don't put enough pressure on, you'll actually get air leaks and your torch won't ignite. So what we built was a Helix CT for constant torque. So just like the petrol cap on your car again, as you tighten it, it'll hear it click. That's finger tight. So now it's got the same pressure each and every time. So we actually measured the different torques to figure out what was the optimum torque. So on the graph on the left there, that's looking at arsenic. You can see the drop-off as you over-tighten the helix or put pressure on that seal. So each spray chamber now goes out with a Helix CT and has the constant torque. We actually set that to optimum sensitivity. So all you need to do is slide your nebulizer in, tighten the Helix CT until you hear it click. Then it's got the same pressure each and every time. When you compare a spray chamber that doesn't have a helix versus the spray chamber that does, what you'll find is the Helix spray chamber gives you that faster washout. And one of the reasons it gives you that faster washout is because if you have an O-ring spray chamber, you have this dead volume here. That dead volume, you've got samples sitting there. It takes a long time to wash that out. So we actually designed the spray chamber with that seal that sits in that dead volume. The sample can't sit there now because that's where the seal is, and sample is now forced into the vortex, giving you faster washout. In the diagram on the right, you'll see an old spray chamber with O-rings. One of the issues with the O-rings, as you're using concentrated acids, eventually they will degrade. If you're using solvents, they'll degrade much, much faster. So what happens is they actually swell up with the chemicals that you're using. Eventually what will happen if you don't replace them, they'll swell up so much that you won't be able to pull out the nebulizer. And in doing so, you'll finish up like this customer did, snapping the nebulizer inside the spray chamber. Then you become a very good customer because now you have to replace the spray chamber and the nebulizer. So the Helix CT is actually inert. So that is your other benefit of having a Helix CT. So most people will be familiar with a one-piece torch. So one of the things with a one-piece torch is, once the torch devitrifies, and that's where the end of the torch is corroded or becomes opaque because of all the samples you're running, or if the torch cracks, you have to throw away the entire torch. So this is where the D-torch was born. So the D-torch, all we do is just replace the outer tube. The D-torch is a semi-demountable torch. And so all we do when the torch devitrifies is replace the outer tube. It's about a third of the cost. Okay, and then off you go again. You can have different injectors. You could have a lumen injector. You could have a quartz injector. They pull out easily. If you want, you can even have sapphire injectors if you're looking at extremely low levels. So a lab that's running through 3 to 4 quartz torches a year, you would pay one of these D torches off in that time. And then you break even, that's your break even point. And after that point, you're saving money on every torch. In situations where you are going through lots of torches, we also have a ceramic outer tube. Now that will last for a number of years, providing it doesn't roll off the bench. So you'll find for most instruments now, there is a D torch available for it. One is you can't see it through it, and we've talked about a few times of people who have been in the industry for a while and they try to look at it. You can't see through ceramic, but that's about it. One of the advantages of it is it runs hotter, the ceramic. It's a better conductor of heat. And because it runs hotter, there's less salt build-up, okay? And you don't get the devitrification that occurs with quartz, which is a natural process, okay? You do get improvements with certain wavelengths, not all, but certain wavelengths, because it runs hotter. So it does depend on the wavelength. Okay. So anyone who's using internal standards, what we recommend to introduce them, we use a product called the Trident. So this is a diagram of our Trident CT internal standard kit. Again, CT stands for constant torque. So what we have is a glass T-piece, no dead volume in there. And on the ends of that T-piece, we've put those ratchet fittings again. So we all comes as that individual kit. And so with the advantage of having the peak fittings, what we have is our sample, we have our internal standard, mixing to the nebulizer. And because they're ratchet fittings, again, what's fingered tight, turn it until you have a ratchet sound, and there it's done. So that's how we recommend applying internal standards online. No metal components again. Zero dead volume, constant torque. You can't over-tighten. So another product we come up with, anywhere where you have a reservoir, so your rinse solution or your internal standard solution, if you put PFA tubing in that vessel and your vessel was full at the start of the run, you go home, as the run goes through the night, what happens with PFA tubing is that it actually floats. It's not heavy enough. So halfway through the night, what you'll find is the level actually goes below your PFA tubing that's floating, and you'll finish up sucking up air. Then you'll look at your Datamine software and you'll see all your QC flags floating. So what we did is we come up with the PTFE sinkers. So what we do is give you 1500 ml of tubing. We fuse that tubing into a PTFE sinker. We round the bottom so it won't finish up sticking to the bottom of the reservoir. And then that tubing can simply be pushed into your pump tubing and the sinker sits on the bottom. So it's eliminated that problem occurring. And you can use that in anywhere where you have a reservoir and you're pumping up from. Contoured flared end peristaltic pump tubing. So if you're using internal standards, you'll generally find the ID of your pump tubing is quite small. It could be 0.25, 0.38, and you're trying to put in a sample line which is 1.3 millimeters OD. So every morning you see somewhere there like this in front of the ICP, trying to join them together. So what we do is we take our pump tubing, we flare it in-house, so now each of the ends of the pump tubings are flared, and it makes it much easier to join those pieces together rather than watching someone every morning do this before they start their run. In terms of part numbers, all you need to do is put an F on the end of the existing part number and it'll turn up as flared pump tubing. One of the questions we get asked a lot is, how do you clean a nebulizer? So this is when we designed our tool called the Eluo. The Eluo is a nebulizing cleaning tool. So if you have a glass concentric nebulizer, you use the Eluo up the top there, and what you do is you slide the nebulizer into the workhead, lock it in place, and then very carefully close the plunger and with cleaning solution and back flush your nebulizer. And that's how we remove any particulates may have been caught in there. If you have one of our polymer nebulizers, such as a Duramist or an Opal Mist, all we need to do is just change the workhead, okay, slightly larger, because these workheads are much bigger on the gas arms here. So what we do, we make a slightly larger workhead, and then we can slide the polymer nebulizers into the Eluo as well. Never put any wire down a nebulizer. Never put the nebulizer in an ultrasonic bath. Otherwise, you become our best customer. It's the quickest way to damage a nebulizer. So if you do get particulates in your nebulizer, the best way to prevent that is using the Guardian inline particle filter. So this is a reusable filter. It has 120 micron inside. It's a bit like a honeycomb. If you put it up to the light, you can see little holes. And you insert this just after your auto-sampler probe, before the nebulizer. And as I said, it's 120 microns. The capillary of a nebulizer is 75 microns. If you block this, you will block your nebulizer. It is much easier to clean this than your nebulizer. It was originally designed to look after nebulizers, and then out come these fast, high throughput valves. And so just about every lab we go to these days, you will find one of these inline particle filters just after the auto-sampler probe, and what it's doing is catching the particulates before they go into the high throughput valve. All the high throughput valves, the stator and rotor, are made of a softer material, generally of PFA or Teflon, and that's because they flow to create a seal. But if you get a bit of grit inside those valves, as the valve is going back and forth, you'll finish up grinding a groove, and guess what? That's when your valve will start leaking. Now you've got to replace the valve. If you're lucky, you might be able to replace components of the valve. So it's far easier to actually prevent the particulates getting into the valve before that occurs. It's been on the market for a number of years now, and we've had none wear out. How to clean it, because I did say is a permanent inline particle filter. So you can take your Eluo that you had before, and what we've got is an adapter. We screw the adapter onto the end of our Eluo, we move the ratchet fittings, and on the inline particle filter there is an arrow direction of flow. So what we do is we reverse that and we actually blow it out backwards. And that's how we maintain it. Other things, that works so well, so then we decided to add it to the gas line on the nebulizer as well. So here we have an inline particle filter for the gas line, but we also introduced a non-return valve on that. So we would implement this between the instrument, gas line, and the nebulizer. And the reason we've got the non-return valve there is depending on how you shut your instrument down, sometimes liquid may actually go back down through the nebulizer, down the gas arm, and then all the way through to your gas box, causing an engineer to come out and fix your gas box. Not anymore with the non-return valve. So there's two components here. It protects solution going back into the instrument when it shuts down, and also any dirty gas coming through, and particularly it's actually blocking the nebulizer, which can happen. So any of you are doing high TDS work, so fusions, soil digestions, wherever you've got high TDS and you have sample TDS salt starting to build up in your injector or salt build up in your nebulizer and block your nebulizer, what you need to do is introduce an argon saturator. So what that does is it's a vessel that holds water. You take your gas line from your instrument, it goes into the vessel holding the water, then from that vessel to your nebulizer. you are wetting that argon stream. That will minimize the chance of the salt precipitating out in your nebulizer and in your ejector. That vessel we call the Elegra. So there's no metal components. We're using the ratchet fittings again. There's an on-off switch at the top. You can leave it plugged in all the time. It's no longer pressurized. And the reason it's no longer pressurized is because of the new technology of one-way membranes. So inside there is a one-way membrane. So water can seep in, but gas can't seep out. Where the previous argon saturators were pressurized. This is no longer pressurized because of the new technology of these membranes. Simple, compact, and easy to use. So then we did some stress tests. So the red line is where there was no rinsing. We ran a 25% sodium chloride solution using a nebulizer. It lasted 5 minutes before it was completely blocked. So then we turned on and connected it with an Elegra, and we were able to get easily 30 minutes. Here's some results from one of our customers. So this is in a stability in 0.5% lithium metaborate sample matrix. They were using 3 internal standards. Now, if they were using Datamine software, they would have found out after 35 minutes, all their QCs would have been failing as salt started to build up in the nebulizer and in their injector. But when they went back and repeated it with the Elegra in place, they were able to get 4 hours of operation and then passing all their QCs. So argon humidification has been around for years. What has improved is the devices that's used to generate that. Ours has no power. Okay? Just a simple membrane and no metal components. So then we wanted to show some of the products that we talked about today in a long-term stability test. So using a 3.5% sodium chloride solution, we had the Elegra. We had the C-spray nebulizer, DC. We used the twister spray chamber, which has the baffle, creates a finer mist. And we used the D-torch. So this 528 minutes of reading the same sample over and over and less than 1% precision over that time period. So if you enjoyed some of the things that we discussed today, please go have a look on our website. What you'll find is some maintenance and installation videos there, webinars, catalogue, newsletters, application notes using some of these products. We have search functions on there as well. And you can go products to suit your ICP. So some of the products, if you know what your ICP is, go to products to suit your ICP and you'll have a list of those products there for you. Thank you very much for coming along today.
That was a great technical presentation. Obviously, things have come a long way, and great to see all the engineering feats, you know, to make things consistent between people, and it's excellent. So, yeah, thanks for coming along and presenting. Any questions for Brian about ICP technology?
Question on the lifetime of the ratchet mechanism.
So it's a question about the lifetime on the ratchet mechanism.
It will be a consumable. It's made of peat, so it is long lasting. I guess it depends on how often you're changing it. But the actual ratchet mechanism itself, I'm not aware of any failing.
We actually used the Elegra humidifier.
Yes.
And made a adaptation to it where the lines come out of it, they were kinky as they come out of that ratchet. So we're sliding over a piece of pump tubing basically to give it a little bit of flexibility as it came out. Is that the new ones you have there with soft tubing, is that in response to that instance or?
So could I just repeat, so that question about kinking on the Elegra unit and perhaps new and old models or something.
So one of the things we try to do is get out to visit labs, listen to what they have to say, and we take that information back and we try to improve the products. If you're having the problem, the person next to you is having a problem. And that's how the soft tubing was born. Okay? And so what we've done, you'll see it rolling out, soft tubing on the nebulizers, soft tubing on the Elegras as well. Okay? So part of that, it's actually PVC tubing, but it's actually finding the mechanisms and how to connect that as well. And so that's where the research and the R&D development comes with that piece. So it's still quite easily connect. It's just soft tubing now.
Anybody else? All right, great. Thanks, Brian. Give him a big round of applause. Right.